Oh, someone told me sigma, right? No, I
It's
don't think.
Sigma.
No, hold on. All right, some things. Zip it over there. Okay. All right. This is mu, though, right?
Yes.
Mu. All right. Mean. This is the letter mu. Okay, I didn't give you these three things. Actually, I forgot. And then I looked at the worksheet doing the key, and I'm like, oh, I forgot those three things. Saw it at the end of McGrath's notes from last year. Put them down, and then I'll try to make sense out of them, and then I'll tell you where my mistake came from, which I got to do more investigation to get a better feel for this as we get going. But mean, what does mean mean anyway? It means average, okay? So you find mean by just taking the amount of trials. If you can get back into yesterday's notes, we had X amount of times we're going to visit a house. In this case, we randomly look at 6 houses. So n is 6. And then p, we got to get that down as that is the probability of success, whatever we're looking for. So we're looking for houses to have cable when we're trying to find them. So the probability of a single house having cable is 65%. And, I searched to try to find out what does mean actually mean in this, binomial distribution situation. And I guess the best thing you could say is, on average, 3.9 out of 6 houses should have cable if you selected any 6 houses to look at. Okay, and I guess that's the best representation of that. Variance, now I guess I better do this. So I just wanted to show that real quick so you know that these numbers are going off of this house example. The 6 choices, or 6 houses we're looking at, times the 65% chance that an individual house will have cable. But then the next thing is, remember I put this down because I liked it, the Algebra 2 formula, where P is the probability of success. We need to know that as a variable. Then I said 1 minus P is the probability of failure. Well, you better get down that actually is denoted as Q in a lot of formulas. Because you will get a formula sheet for the test, but you will need to know what the letters mean and when to use any of the formulas. That's the problem. So do understand that. So variance is whatever this letter is squared. You think it's what? Sigma. I'll ask fifth hour because they also, and then we'll put it all together. Squared equals n times p times q. Q being the probability of failure. That's why I wanted to make sure we understand that. So again, I gave you an Algebra 2 formula because I liked it. It made sense. But we actually need to know what Q actually stands for. Standard deviation then is just the square root of that data, or square root of that previous variance. Let's write those down. We'll discuss more standard deviation, I guess, as we get into this stuff. But what I'm going to do for mean is describe where my mistake was, although it kind of blows my mind still. And actually, we could see, look at your notes, and look at the change. It's obviously in blue. And I guess it's a perspective thing. The way I thought of skewed was where more of the data is. But actually what it is according to Mrs. Truesdale as well, looking at this stuff, is if I were to find the mean of this example, the mean would be right of most of the data. So therefore it's considered skewed right. The average is right of most of the data, so skewed right. I told you this was skewed left because I had a different incorrect perspective. Whereas let's hammer that down with symmetric. Well, if the probability of this succeeding is 50%, or the probability of 50% of X amount of houses having whatever, and you checked 8 houses, obviously 8 times 0.5 is 4, and 4 is the mean that cuts this data perfectly in half. So that's why it's called symmetric. So using the mean as an average of, figuring out that. And then when the probability is 0.9, the mean will always be a little bit left of most of the data when you actually find it. So that is actually considered skewed left, not skewed right. So I do have a problem with it as well. I feel like all of the data is on the right, so there's mostly right, so it feels skewed right to me, but it's actually opposite that. Whoever decided to come up with these terminologies. All right, so make those corrections if it's ever asked of you, and then just know these formulas. Again, you'll be given the formulas, but they just may not have names on them. So you might have a problem with trying to figure out when to use which one. We'll try to help you out with that as we go through the rest of this chapter. Okay, now let's go into today's, which is actually real short. And I'm using Mrs. McGrath's notes from last year just because. I don't feel like rewriting them. Okay, last one is geometric and, I don't know how to say that, Poisson distribution. Anyone take French? Someone says in French that means fish. Right? Okay, now, we had binomial distributions yesterday. Geometric and Poisson distributions today. There are three different types of questions. Three different types of scenarios, I guess. And you'd have to decide, actually, at the beginning of your worksheet that you should have picked up when you walked in, when to use which. It's a little different when you actually see the question. It's a little different setup or a little different worded, what you have to find, compared to a geometric scenario. So trials are repeated until a success occurs. There's the difference. Number one. Yesterday you just had, we visited a house 6 times. And then you were just asked questions. What's the probability that exactly 2 out of 6 houses have cable? Really has nothing to do with this type of question. You do trials until you get a success. Repeated trials are independent of each other. That just means one doesn't affect the other. That's what independent means. We'll talk about that word in 10.3. And P remains constant for every individual trial. Okay. So here's the formula for that. Yet again, there's the letter Q. What does Q stand for again? Probability of failure. What's P stand for? Probability of success, which will be aligned in the question. The question will be, or the probabilities will be from experiments, or actually seeing what happens over amount of years, and then we extrapolate what the probability has happened in those time frames. Okay, sorry for the cheap seats having trouble seeing it. I just don't want to reveal too much. Probability that a person will pass a CPA exam is 23%. This is based off of data already out there. For the past 5 years, those students that said this is their first try, 23% of them pass. Heard it is a tough exam. Find the probability that the first time Shelly passes is... Well, what's the probability she passes on her first exam? It's right in front of you. What is it? 23%. That's it. That would be easy. But that's not what we're asking. We're asking, what's the probability that the first time she passes is her 5th attempt? Then we can make sense out of this formula why it works. This means she failed on the what attempt? First and, but then what does she do on the 5th? Pass. What's the probability that she fails on the first attempt? 77. Second attempt? 77. Third? 77. Fourth? 77. Then what's the probability she passes on the 5th? 23. So you can see how this lines up in this formula. All right? 5 attempts. 5 minus 1 is 4. If we line this up specifically with the counting principle using probabilities, it'd be 0.77 times 0.77 times 0.77 times 0.77 times 0.23. Just a faster way of doing it. And that's what I'm thinking. Good. Happy birthday. All right. Yeah, that did actually. All right. So the probability is 8.8 0.1% if you labeled it that. You know, these kind of questions, just the ability to read this. What's the probability that she passes before her fourth attempt? You just got to be able to read that. That means she passes it on her first or second or third. So basically, you have to add those three probabilities. And this means it's more than likely that someone will pass it on one of those three. Maybe not the first, maybe not the second, maybe the third. You know, blah, 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 blah. And then, I don't think we need this for the movie much. There's the use of the formula. What if it just asked after her third attempt? Well, that's a problem. That means the what attempt? No. After her third attempt is when she passes. So she waits till the fourth or how long can this go? Forever. So fumble, that's your phone, by the way. So can you actually do that? Go off to infinity. So no, what should you do for letter C? Subtract. What? The complement. What's the complement of this? 1 or? You're not going to do 0 attempts. 0 would never be plugged into this formula. Oh my gosh. Hike. It'd be 1 minus the complement of that statement. Right? So what we're saying is this. If I didn't ask you B, you would have to still do B to get C's answer. Right? Yep. Because C is just the complement of B, or B is the complement of C. So for me to actually assess this, I would actually have to find the probability of her third, second, and first attempt, and 1 minus that to actually answer this question. So you just need to understand that, and I don't know why you wouldn't after I just explained it. This sticks out like a sore thumb how different this is compared to a binomial distribution or a geometric. The experiment consists of counting the number of times an event occurs in a time interval. I joked with my last hour student. On average, student A will say is not paying attention 6 times during a lecture, on average, every class period, which is 51 minutes. So you actually assign a number of how many times you observe something over a time period. Then you can ask, during the next lecture, what's the probability this student will not be paying attention 8 times during the notes? That would be the kind of question you'd have. Probability is the same for each trial. That means things don't change as you check from one event to the next. The number of occurrences in one interval is independent. There's that independent thing. That means one check doesn't affect the other. We'll talk about independence in section 10.3 more thoroughly. Here's the crazy formula. I'm not going to tell you where it comes from because I don't know. I do like, I tried to do that with binomial distributions yesterday. I tried to show you where that C came from, the combinations. Why are combinations all of a sudden in there? And I did do that. Okay, this is mu again. Or really stands for mean. And then raised to the x over x factorial. X is the amount of trials you're trying to see have happen. And then E is E. Who's in CAT last year? Raise your hand. You remember E? No, not Euler. E is approximately 2.7. You're right. 718. 2.718. Okay, and then there's M again, or mu. And raised to a negative power. Someone asked me a great question. If E's raised to the negative M, why didn't you just put it down here and raise it to the positive M? They're right! Negative exponent rule? Ooh, some people are looking at me like a deer in headlights. You ever see the negative exponent rule? Do you know what they're talking about? Yeah, 7th grade? Wow, nice. Okay, so you observe data. All right, and then this like I said, that student example. I observe the student, and on average, I catch them 6 times not paying attention to the notes. Well, the mean number of accidents per month observed at a certain intersection is 3. That's what the mean, or mu, is in the formula, and it goes in 2 spots. So again, this sticks out like a sore thumb because they're not giving you a probability of something happening. They're saying this is how many times something happens per time period. What's the probability that 4 accidents occur in June? Big whippity-doo-dah, just so you know where the numbers occur. But again, remember, we'll give you the formulas, but we're not going to name them, and you're going to have to know when to use them. So through your practice of doing homework, hopefully you get those things figured out. And then one thing I do have to do for you is, who has an Inspire? The Inspire, the E is right as one of the buttons. It's on the far left somewhere. For an 84, it is a little not hard to find, but it is a little sneaky. And then if you have a scientific calculator, when we're done with the notes, I can help you find it. So just so you know how to type it in. But first of all, mean, 3 accidents a month, and 3 goes here. 4 accidents occur. X and X, that's how many, put that down, please. All right? It's ridiculous. Yes, this is a senior class, although. All right. 3 caret 4 times, and then just to show you where E is on an 84, it's second ln. By the way, ln is natural log or log base E for you cat students out there. Actually, you Math 3 students, you should have seen that last year. You did a lot of logarithms. Negative 3. I just press enter. Then I divide it by 4 to remind you where factorial is, PRB. Then I divide that by 4 factorial. 16.8% chance. Okay? All right, and then the same old silly questions. More than 2 accidents occur in October. What does that mean? How many accidents occur? Not 2. More than 2. 3 or all the way off to what? No, infinity. Right? So can we actually do that? No. We have to do 1 minus the opposite of that. And in this case, you can have 0 accidents. Somebody said 0 should be in the last setup here. I don't really care if someone takes the test 0 times. 0 is not an option from the last one, right? But 0 is an option for this because you could have 0 accidents at that intersection on a given month. So more than 2, you can't do that because it goes off into infinity. You have to do 1 minus 2 or less, the opposites, the complement, if you will. And then all they did is show you 3 to the 0, e to the negative third, over 0 factorial. Here's another instance where 0 factorial has to equal 1 for another formula to actually work, just like permutations and combinations. And I told you that. All right, and then this is when you plug in 1 into the formula, and when you plug in 2, you can check that yourself. I'm done.